Hi, this is a video about making tension specimens for member tests, making a bridge out of file folders and making the pieces that we need to figure out how strong these pieces of the bridge are going to be. Essentially what we're trying to make here is a long strip of file folder material of a known width that is supported by tape at one end and by our fingers at the other end. We're actually going to use this spring scale to test the strength of that piece of the bridge. I'm going to start out by making a very, very tiny strip. And you'll find actually that even a very, very tiny strip can be really strong. So I'm going to look closely here and I'm going to make something that's exactly 2 millimeters wide. I'm looking at the very edge of my file folder and I'm making a mark 2 millimeters in, being very, very careful that that's exactly 2 millimeters in. I will then go to near the bottom of my strip of material here and I will make another mark exactly 2 millimeters in. Notice that there is some uncertainty even in the width of my pencil line. So there's going to be uncertainty in the width of your specimen here, but you know, that's something we have to deal with. It's going to be real when you cut it as well. So I'm actually just going to go ahead and get out my X-Acto knife and cut this. Notice I'm using the side of the ruler that has the cork up because I want the metal part of the ruler to be as close to the material as possible. I'm going to press pretty firmly, making sure that I'm holding it against the metal ruler. And I'm actually going to go over this again so I know that I got it. And I have my 2 millimeter wide strip of material here. Now you may want to adjust the length of this if you're curious to see if the length actually affects the strength. That's up to you. I'm just going to leave it this long for now. And I'm going to show you how to use tape to support one side of that. So I'm going to tear off like, 10 centimeters, 8 centimeters of tape. And this is a little bit tricky, so I want you to watch carefully. I'm going to lay the specimen over the center of the tape about halfway down and press it down firmly. Notice I didn't get it exactly in the center. That's okay. But I'm going to fold the tape over in thirds. I want actually 3 pieces of tape covering this just to make the tape part stronger. Believe it or not, this file folder material is very strong. So in order to support it on this end and pull on it so that the tape isn't the part that breaks rather than the file folder, we need to support this by a few layers of material. 3 should be enough depending on how thick you go with your member. The next step I'm going to do is to try to make a hole in this tape. You might find that the X-Acto works well as long as you're really, really careful. You can, about 1 centimeter in, just push and twist. That is, like, spin the X-Acto around. You may find that a pen is useful here oops, I broke my pen. But a pencil might be useful here. You want a solid hole because the next thing that we're going to do is put the hook of the force meter through this hole. I'm actually going to grab the other end just with my fingers. I'm going to use as much friction as I can by squeezing my fingers together. And it's important that I know exactly where I'm holding the specimen. This is another way that you can change the length by just holding it here versus holding it here. So I'm going to actually put the hook of the force meter through this hole that I made, which is why it's important that that hole be pretty effective. And then I'm going to make sure that my force meter is zeroed, and then I'm going to perform my test. So I'm holding it over here, and I'm going to look carefully at this force meter as I pull harder and harder and harder until I see it break. It'll be your job to look carefully at this to see exactly what value this reached. It looked to me like this reached maybe 30 or 35 newtons. You'll need to figure out a way to make sure that that is very, very, very effective. And you'll come up with an experiment to figure out how different factors affect the strength of the member. I will warn you, even something that is a centimeter wide is going to be too strong to break with this 50 newtons force meter. This paper is very, very, very strong under tension. We'll next talk about how you can test things under compression. Notice that this paper is totally, totally weak and feeble under compression. When I push it, it doesn't take any force at all to make it buckle under very, very little force. So there's a big difference between the tension that I can put on this member and the compression. We'll talk about testing compression next.